while we look at a third example, let me see if I can actually show you properly how to write out your solutions as well. Yeah, I'll see if I can do it in this format, so you can see how to properly present your workings as well. So I can teach you multiple things at the same time while solving the problem and also the formatting. Yeah, we'll see how this works. Yeah, so let's look at this one. An object is launched at 30 degrees above the x-axis, okay, at a speed of 12 meters per second from a cliff of 100 meters from above sea level. So my strategy is always when I read a question like this, so this will be a more involved problem. As you can see, it has multiple parts. It asks one thing, another thing, and then a third thing like that. So in order to do that, I'll always start with drawing a diagram. But first, so over here, you want to label your problem. So let's say question 3 like this. And my strategy of drawing a diagram is to do it line by line, right? So the first line and stop over here. Don't draw anything else. So first, your goal is to translate all the information you have in the first sentence down here. If you do line by line, you'll always you will never miss any information, right? So you'll be sure that you have all the information you need and you haven't missed anything. Okay, so it launched from a cliff. Okay, so I'll sketch a cliff, and as simple as it can, it will do. It's launched 30 degrees. Okay, so somewhere like this, right? 30 degrees above the positive x-axis. All right, so I'm going to define my x, y over here, and at a speed of 12 meters per second. So u is going to be 12, like that. And oh, it turns out a little bit small over here, but hopefully you can still see it. A cliff 100 meters above the sea level. All right, so that's 100. Okay, like that. All right, so let me check. I have all the information. I have 30, I have 12 like this. It's launched. Okay, good. So I'm confident I have everything over here. How long does it take? Okay, so my aim, now I'm gonna state my aim. It's in fact, there's a couple parts. So let's state them as part A. The aim is how long it takes to land in the ocean below. All right, so there's the ocean. So I want the T to ocean. Okay. And what is the velocity and the speed when it lands? All right, so the velocity when it lands and also the speed. Okay. And at what angle does it hit the sea with, right? So part C, the angle it lands, basically. Okay, so there's a couple of parts. There's even more. So what is the maximum height reached? All right, so it looks like it will go up and down like this, right? So we also want to find the maximum height and how long it takes to get there. All right, so time, notice this is the time it gets to the ocean. With this time we want to specify the time it gets to the max height. Okay, something like that. All right, good. Now, all right, so these are everything we need. So we can write out at the other side before I properly solve it over here. I like to write out all my givens. So what do I know? At first, I want to find the ocean. So that means I'll usually sometimes sketch the path as well and pick that as my final point and that as my initial point, right? So we want to predict the future essentially given all the present, right? So I'll write SX, UVAT, my suvat variables here, and my suvat variables here, and to put X, right? Like this. Okay, so I'm comparing my initial to final point over here. Do I know SX? So SX is the displacement in the X direction. So I don't know anything about that. So that's question mark. SY I do know, right? So I go from here to here. What's the displacement? It's 100. Positive or negative? Negative, right? So we'll put minus 100 over here. UX, do I know my UX? I do. I have U over here, so I can resolve my angles. So this is going to be, I'll show you exactly how I do it, right? Usually I will use the quick trick immediately. I know that that's sandwiching. So immediately here, I will write 12 cosine 30 degrees. Cosine 30 degrees like that. Maybe I'll try to make that a little bit more spacious so we can see it clearer. And uy, if one is cosine, the other one's got to be sine. So that's going to be 12 sine 30 degrees. It is a little bit small. Sorry, I'm just experimenting with this format. We'll see how this works. Maybe I'll keep in mind to write a little bit larger here. Okay, Vx. All right. So I usually put that last. We'll look at acceleration first. Is there any x acceleration? No, but there is a y acceleration, right? So there's no acceleration because there's no force in the x direction. There is an acceleration because there is a single force pulling it down, right, during this process. Okay, time is in fact the thing that we want to solve, right? So that's my question mark. And Vx, Vy, I also don't know. All right, so question mark. Okay, good. So I need 3 out of 5 pieces of information. Let me look at x over here first. Can I zoom in? Yes, I can. All right, so I can hear you sigh of relief right now. All right, so if I look at the x side over here, I don't have 3 out of 5, right? I only have 2 pieces of information, so I can't do much with the x. But here I do have 3 out of 5. So I want to find the time. So I'm going to pick the equation with no v. All right, so I will use the other 3 information to find t. All right, so which one is the equation with no v? If you are unsure, usually I have them memorized, but if you're unsure, you can do this in the exam. You can write out all the 4 equations first. And if you like, you can even label them, which one has no whatever. This one has no S, no A, no V. That's the one we want, right? And no T like that. But with some experience, you can keep them in your head, but I'll leave it up to you. You feel free to write this on the side, right? Okay, so we're going to solve part A, and I'm going to use the no V equation. So I'm going to do S equals to UT plus half AT squared. I'm leaving a little bit of space so that I can label Y. I don't need to label the T. And now I just have to plug in the numbers. So I have minus 100. I have 12 sine 30. Notice I didn't do the math either in the calculator or in my head while I am writing this, because the first step, I'm showing the grader what equation I'm using. Basically, I'm trying to write it in 2 ways, for 2 purposes. Number 1, so I can get the maximum partial credits in an exam, because every step I'm only showing one thing. So I show the examiner, I know which equation to pick. I know I'm plugging in the correct numbers, etc. If you do 2 steps in one step, if you do 2 things in one step, and if you made a mistake, you will not have the chance to get a partial credit. You get 0 for that step, right? So this is a way to maximize your partial credit. But forget about exams. You might wonder, hey, I just want, I'm here for learning purpose, right? I'm here for a noble goal of learning. I'm not here to just get the pesky 1 or 2 points. In that sense, in that case, then your goal should be to present the solution in a very readable and understandable way, right? Don't you hate textbooks that sort of jump steps and you have no idea where things come from, right? This is a way, right, to present it in a very understandable way. So it trains you how to write things professionally, and it also incidentally coincide with the maximum amount of partial credits you can get in the grading key, right? So double benefits for doing this, right? Anyway, continue. Minus 9.81 t squared. So I'll actually use the 9.81. Let's try to write this clearer, so we can mimic proper solution writing. Okay, and the next step we'll do the algebra. All right, so we'll simplify that. 12 sine 30, you can pull out a calculator, but I know sine 30 is a half, so I can immediately write that as 6t plus 9.81 divided by 2. So I also have negative, so I'll write that, and we'll pull out the calculator that says 9.81 divided by 2, it's 4.905. So I have minus 4.905 t squared. Okay, all right. So as soon as you get to this step, let's say there's 5 points allocated to here, the rest is algebra, right? So you should at least get 3 or 4 out of 5 points. This one maybe 3 because there's another subtlety going for at the end. But yeah, you should at least get over 50% of the points over here, and the rest is what I call algebra steps. All right. So we still need to do it, even though it's algebra. So let's do it. Right. So the rest, I just want to emphasize, now it becomes a math problem, no longer a physics problem. The math problem is you need to solve t. All the physics is done, right? It's all over here. Okay, so math problem solving t is, as long as you see a square, ask yourself, maybe quadratic. It's a quadratic equation, so probably the quadratic formula. So let's write that as sort of a b in the ABC format first. So we'll put that as 4 point. I'll try to write that larger, like this. Sorry, minus 6t minus 100 equals 0. And just to, so now the quadratic formula will tell me it's minus 6 plus or minus square root, that longer, and 6 square or minus 6 square minus 4ac over 2a. Okay, and this is the point where you can plug in the calculator. There's plus or minus, so you might want to do them separately. So we'll do the plus first. So I'll have 6 plus square root. I'll do this in real time to show you how it works, right? And 4.905 times minus 100. And I need a big parentheses outside. Oops. Let's insert back that in and divide by well, 2 times that, but I know that came from the 9.81. So just to make the calculator do a little bit less work, because let's be nice to them. It's 5.16, right? So I get either 5.16. Let's keep 3 decimal place for now, and then we'll round it later. It's always good to have more than enough at first. And let's do the minus. And I think I can cheat by just changing that. And I get the second answer, minus 3.94, let's say 5. All right, so now you want to ask yourself 3 questions. Should I reject anything, plus or minus? Sorry, reject any plus or minus, significant figures and units, right? So I have 2 answers. I'm looking for the time it reaches the ocean, right? Remember, so that's the math part. Let's see, so this is the math part, right? This is the physics part. This is the math part. And now you want to go back and answer a little bit of physics question is which one makes sense, right? All this is math. So if you made a mistake here, and most you will get 1 point deducted. But there is a physics in terms of the choice, which one you choose. So should I choose the positive time or the negative time? Negative time means it happens before. If the time is 0 over here, right? It happened before. Well, it did not reach the ocean before. In some sense, you've calculated when would it start at that height. But that's not what we want, right? So that's the one we need to choose. So we're going to write the physics part, which says, therefore, the time to ocean, you don't need to write full sentence as long as it's comprehensible. That's fine. Time to ocean is 5.1. What are the decimal places? It looks like everything is sort of given in, the least significant figure is 2 sig figs, I think. It's not 12.0, so we'll go with the least one because that's the most accurate. That's the most accurate one that it's reliable with, right? So we'll use that as the significant figure. So I would go with 5.2. Okay, so that's the first part. All right, so feel free to double check my math as we go. So let's split this in the second video and we'll go faster for the rest of the problem. Okay.